Okay, mean value theorem explanation, take number 2. So I will just try to explain the mean value theorem with the general rule and then apply it to an example. Over here, y equals x squared, and hopefully it will make great sense to everybody. Okay, so here's the mean value theorem. If we have a function f of x that is continuous on the closed interval a to b, a comma b here, and is differentiable also, that's important, on the open interval a comma b, then there's at least one point C, within a and b, such that this happens right here. And this is basically the most important part of the mean value theorem. And what does this mean? F of b minus f of a over b minus a is the slope of the secant line that goes through these 2 points. It goes through a comma f of a and b comma f of b. So the slope of this secant line right here must be equal to f prime of c, and c being some value, so there must be at least one value, c somewhere, that will have a tangent line that will have the exact same slope as the secant line that passes through a and b. So that is the mean value theorem. And we're usually going to be expected to figure out what this value c here is that will provide us with essentially a tangent line that will have the same slope as the secant line going through those 2 points. And so let's try to apply that over here. We have y equals x squared. And let's say that we want to figure out a value between 1 and 2. Okay. Sorry. Okay. That would give us the same slope as the secant line that passes through these 2 points right here. So first let's calculate those two, or rather, yeah, those two values. We actually already wrote them here actually. So we got f of 2 minus f of 1 over 2 minus 1. So our b is 2, our a is 1. So essentially I'm just using this right here, right? And what is that going to be equal to? Well, if I plug in the 2 for x squared, I get 4. So 4 minus f of 1, if I plug a 1 in for x squared, 1 squared is 1, over 2 minus 1. So I get 4 minus 1, 3 divided by 1, 3. Okay, so that is the slope of the secant line passing through those 2 points. Now we're going to have to figure out the value of c somewhere between 1 and 2 that will have a slope of 3. So how can we do that? Well, first let me take the derivative of y equals x squared. So f prime of x is going to be equal to, well, a piece of cake. I can bring down the exponent, multiply it, and then subtract 1 from the exponent. So f prime of x is just 2x. So the derivative of x squared is just 2x. Now I will set the derivative. F prime of x will be equal to 3. So 3 is equal to 2x. And then I can solve for x to figure out what that value is. And x is 3 over 2. 3 divided by 2 is 1.5. Oh, look at that. 1.5 is between 1 and 2. So it looks like the mean value theorem is correct. And of course, y equals x squared is a continuous function. It's differentiable basically everywhere. So the conditions for the mean value theorem are satisfied. And of course, the secant line, or the tangent of the secant line between these 2 points here will have the exact same slope as the tangent line passing through the point where x equals 1.5. So that's it. Hopefully this makes good sense. And if not, please take a look at a few more examples. Good luck.